It absolutely pains me to do this after all the work I put through, but there's no sense in unwinding such a mess, so these things don't even cut it. This is the not so glamorous, tedious, gut-wrenching work that you don't see in my videos. Oh, the horror. Oh, the tedious undoing horror. Realize this is like 2 days of entire work just being undone here. Back to square one. Got our new custom bifilar spool. We're going to be fitting that thing through there, lining this up. Let's see how long this takes. I got my cinematic music playing in the background. This first little chunk, we're doing it a lot better than that last one. Very spacey. This one's going to be very tight. This is getting increasingly difficult. Kind of getting in a groove here. It's pretty not all so bad. My music stopped, therefore I must stop. Alright, version 2 here. We're gonna load this puppy up. Alright, one individual coil measures at 111 ohms, 37 millihenries, 637 nanofarads, a lot of capacitance. In bifilar mode, we have 300 ohms of resistance, 300 ohms-ish. We have 128 millihenries. That's close, but it's not what we were previously. And capacitance is 197 nanofarads. Alright, we are all wired up. Look at that beautiful bastard. Impressive, 130 volts, 7.6 amps, still hovering about 1 amp at the cells. Cells definitely producing as a result of that voltage level. Kind of a crazy waveform here. I need to shrink this just a little bit further so we can actually see what's going on. Not equal opposite. Looks like we've got more positive potential than negative, so we could actually balance this out pretty good. Just as a marker here, that's our setup. Look at how this signal appears to be equal and opposite, but as I crank up to the maximum voltage, well, that time it's growing a little bit. It's swinging more positive, as you can see there slowly. We're going in positive potential instead of negative potential, so it looks like we need to do some balancing here. As we crank up to 32 volts, you see the potential difference grow. Let's see, we're on 3/4 in that cube right there, whereas we're only in 1 cube. And that is 1 3/4. Definitely chugging though. So at 7.9 amps, 127 volts at the cell, 1.1 amps at the cell. Let's see what balancing this waveform will do to that amperage and voltage. Alright, I was decided instead of removing coils from that one, I went ahead and added some additional coils for this inductor B, I guess you could say, part of that secondary, just to see if we can balance it out that way, and what that compares to voltage-wise if we were to balance it out, reducing the inductor A's coils there, the balancing inductor. Alright, got it all hooked up there. Back to a reference point here, what we're working with. 127 volts of the cell, 7.8 amps consumed, right at about 32 volts-ish. Appropriate production waveform, reduce the imbalance there with the positive. Here we added the additional negative inductor, and we still have more positive than negative potential. I'm reversing these two terminals. Still more positive. Voltage is not even as great. Back to bridging. Epic fail. We're just going to remove some of these positive inductor A, the balancing inductor's windings, to match and see what goes from there. We have effectively reduced this coil to right there. We've eliminated that much of that coil. Well, that's still not balanced. I think our amperage went down by like half an amp, maybe an amp. We're still about the same voltage, still about the same amperage at the cell. These capacitors definitely do add a few volts to our setup. What's interesting though, when I take away the cell diodes, we get an entirely different waveform, but we also have more negative potential than we do positive potential now. Alright, reduced the coil to just, I don't know, what is that, 2/3 of it? Maybe? Half? Look at that there. Oh, it's still growing, but more positive potential. Seems to be just growing and growing. That amp consumption, I believe, is down though from 7 point something, 7.5, maybe down another amp. We still have about the same voltage here. We might be able to adjust frequency and get that to, you know, we were at 125, 126, 127, somewhere around there. I mean, cells are definitely producing. As you can see, we got the bubbles. But we still have more positive potential. It's crazy. I'm going to connect our negative inductor windings back. As you can see, we start out pretty equal opposite. Dang near on the money. But as we achieve maximum voltage here, tends to swing more positive. 121 volts at the cell. That's down just a little bit. Amperage is down even more now, but that's pretty close. It's not equal, of course. Let's try just a little bit more tweaking here. Whoa, here we are again. We had some crazy voltages showing up, like, see that 130, 132? That's at a specific voltage. Look at that amperage though. What is going on here? Look at this waveform kind of dancing up and down here. Back to 134 volts at the cell. 1.3 amps? What is going on here? What is going on here? Now, pay attention here. We've got 200 milliamps at the cell at 135 volts. 1.2 amps in. But we are not making the gas like we normally do. And we definitely not making the gas like we should for that voltage level. What's going on here? We've got to have a loose connection over here. I hear something. This does not make any sense. If we have 160 volts at the cell, we should have way higher gas production. I mean, it appears that the cells are producing given the discoloration, but we are not getting gas production, I don't believe. Yeah, like we should. Man, this is weird. Okay, 121 volts, 5.5 amps. I mean, we're cooking some hydrogen out of there. Notice how during our pulse off time, this blue dips way down negative now. I wonder why it is. I wonder if we're having diode issues.
Welcome to Season 5 of Stan's Revenge. My name is Noah Almond. I've uncovered the true fundamentals of the electrical polarization process. This is unlike traditional DC electrolysis, as the disassociation of the water molecule is performed by opposing voltage potential instead of amperage. This allows for the generation of HHO gas from natural water without any electrolyte or chemical additives. In this chapter, I experiment with new cell designs, VIC transformers, and the electron extraction circuit. I'll be improving water fuel cell efficiency and increasing gas production to even greater levels. Join me as I uncover the secrets of Stanley A. Meyer. This is Stan's Revenge.
Alright, so we've drastically reduced the... Ooh, I'm still hot here. Hang on.
Saved his roots.
basically just from here to here, that short amount of bifilar inductor balances it, that little tiny bit. So traditional single coil took the entire thing in many winds. A bifilar coil takes a sliver of that in order to balance that waveform. How keen. Now with the reduction of windings, I am only able to achieve up to about 120 volts or so max. There we go, there's 118. Still under an amp at the cells. I increased the ratio on this here, but you can see we have equal opposite. That right there, that line, let's see here, 1, 2, 3, just over 3 of those blocks. 1, 2, 3, just over 3. That is perfectly balanced. And our amperage I really like is down to 4.4 amps, but we're not at that 127 volt mark that we were previously. Let's see what we can do now as far as adding some of these additional winds back in a balanced configuration to see if we can up that voltage while maintaining the equal opposite polarity. For simplicity, I've removed that single inductor, so all we're working with is that bifilar wind now. Yeah, we've kind of added an additional winding for H1, both of them like in a bifilar mode. So a single coil going from the balancing inductor, bifilar wrapped with the negative coil we have hooked up here. We'll see how this works. What was I at previously in my other videos, reaching 118 volts? What was my amperage? Look at this waveform though, man. That's beautiful. That's almost on the money. Now hold up a gosh darn minute here. According to my previous test results, test 1, 2, and 3, input amperage was at 7 amps. Wow, okay, we were at 7 amps and we were producing hold on. There we go, good enough. 118 volts, what I was doing here previously. So I was creating 118 volts at the cell, but I was consuming 7.23 amps. Hold up. Now, correct me if I am wrong here, but our max voltage at 32 volts input, 31.9, there's my 118 volts. We're at 4.4 amps. Over our average of 7.2 amps, we're down to 4.5 amps. Wow! So multiplied by our multiplier of 3.17 as our previous calculations here, we're down to 450 watts per liter of HHO, down from 740. Which, if we are producing the same amount of gas, which I have no reason to believe not, given we're at the same level there, we have the same voltage at the cell, we have the same visual production, dude, we are really close to equaling the efficiency of traditional DC electrolysis. And that's really important, because we're trying to prove concept here. And if we can prove this concept where we are at least, at the very least, co-equal that energy consumption wise of traditional DC electrolysis, we're still doing this with no heat generation, with 1 amp at the cell, with no electrolyte or additives to the water. So this is pretty freaking awesome here. Phenomenal. I mean, just for, essentially switching up what was a single inductor to a bifilar inductor grants us incredible savings in power. But dude, let's see this just one more time. Let's see what we're doing here. There's our 118 volts. We're actually just a little bit lower amperage wise at the cell, because we're down to 870 milliamps at the cell, is just slightly lower than what we were getting previously. There we go. We're at 1.12 amps. Now we're at 880 milliamps. That's a solid dub for today. Wow. Yeah, buddy. Still a cold process. Still just 1 amp at the cell. Our diodes aren't even warm. Here again, 112 volts there without the capacitor. Connecting those capacitors allows us to go from 112 to 117. Very cool. 117 volts, 4.2 amps, 800 milliamps, 850 at the cells. Nice balanced waveform. That's my present frequency and duty cycle. Seems like as this cell keeps working though, it still builds up more positive potential, so we could still use a little bit more negative potential. So essentially inductor B, in this instance, we have from here to there, we have all of these coils here used for inductor B. Inductor A is from here to here. So if we look at this like that, kind of like as balanced as we can here, this being essentially the middle point here, you can see that we have just a little bit over half of that coil used for inductor B. Inductor A, what I currently refer to as the balancing inductor, is actually smaller. In this specific configuration, we definitely have more positive than negative. We got 123 volts on that cell. 7.6 amps. We are way back higher, but you can see that gas being produced appropriately for 123 volts. That's 5.1 volts per tube. That's impressive. We do not have a balanced waveform, but we have 122 volts at 1 amp with 6.66. Here's 90 volts at the cell at 800 milliamps. That's killer. 94 volts at the cell at 1.14 amp. I'm at 4.36 kilohertz. Interesting. 96 volts at 300 milliamps at the cell, 1.67 input amps at 9.47 kilohertz. We've got a crazy, very distorted, dirty signal, but nonetheless, that's kind of impressive. Alright, well, I can't find the configuration that I previously had that gave me the 4.5 amps that I had. So I'm going to have to review my video here to recreate that. I've been trying a whole bunch of different schemes and whatever for this. I'm able to get up to like 124 volts. That's like 5.1 volts per tube. And great gas production. You're chewing up 7.5 amps or more. But I'd really like to get back to the situation where we were at, 450 watts per liter and go from there. But we've had some great findings here today with the bifilar windings versus the single file windings. I was not expecting this drastic of a there's a difference here, just such a stark difference here between the performance of this thing and the performance of this thing. Albeit, no, this one's wound a lot tighter, nicer, and probably is a little better efficiency. But nonetheless, the bifilar mode is like bifilar everything. Is like the win. It's like the secret to the universe is just do it bifilar. We got the primary bifilar, saves amperage. The secondary bifilar gives us equal opposite. Bifilar, balancing inductor, maximizes voltage, reduces amperage. It's just, man, got a lot more to do.
This is Stan's Revenge.
I said I was done, but I put nice fresh water back in these things. Fresh water tested about 5 volts, so volt per cell. Spicy, 128 volts, still about an amp. 7.35 M, which is about what we were previously, 7.3. It's going up just a little bit, but getting significantly higher voltage. We still have an imbalance here, more positive than negative. See those big bubbles coming out of it? That's how you know your cells need a little bit of time to get those bubbles out. They need a little bit of conditioning. You should not see big bubbles like that out of your cells when they are properly functioning. But yeah, 126 volts is pretty nice. Full blast. That's definitely putting some bubbles out. I wonder what LPM that would be. Maybe instead of 1/3 of a liter, maybe like half a liter per minute. That'd be nice.
I changed the diode polarity. This thing's getting pretty warm though. It's probably putting in some work. But the diode is reverse polarity. I had to switch up my output because of the switch in the polarity. I wasn't getting any output, but that's because I have diodes in and out of my cell, so obviously current flow being reversed wouldn't work. So by switching positive negative on the output, I'm able to achieve this here. 124 at 6.4 amps. I'm hungry and it's time for a timeout and to review and collect what I've done here. Yeah, we are done now.
This is Stan's Revenge.